Hello and welcome to today's lesson on forces and interactions. Our learning objectives are to recall examples of ways in which objects interact, describe how such examples involve interaction between pairs of objects, and recall Newton's third law of motion. Objects interact with each other through forces. But what exactly is a force? A force is simply a push or a pull. If an object pushes or pulls on another object, then it's exerting a force. Now I've got a little experiment for you. I'd like you to try and jump in the air without pressing down on the floor. Pause the video now and have a go. You should find it's impossible to actually jump upwards without pressing downwards on something. The reason is that you push down on the floor and the floor pushes back on you, pushing you upwards. When two objects interact, they always exert an equal and opposite force on one another. This is referred to as an action-reaction pair. If you think about when you go swimming, you push on the water with your arms and legs, pushing the water back. The water reacts by pushing on you in the opposite direction with an equal force. And this is why you move forward, because the water is pushing on you. This is all summed up in Newton's third law of motion, which states for every action there is an equal and opposite reaction. Pause the video now and copy that in your books. Rockets are a classic example of a Newton's third law pair. The rocket pushes on the hot gas, making it move backwards. Hot gas pushes on the rocket, making it move forwards. Action-reaction forces always work on two different objects, so in this case, the rocket and the exhaust gas. When two objects need to touch each other in order to interact, it's called a contact force. If the objects don't need to touch each other in order to interact, it's called a non-contact force. When a football hits you, it pushes on you, and you push back on the ball. This is an example of a contact force. It might seem quite strange to think of something as inanimate as a desk being able to exert a force on you when you push down on it. But desks and everything else are made up of atoms, which are held together with bonds. And these bonds act like little springs. If you try and push the atoms closer together, then the bonds will push backwards like a spring would. And if you try and stretch the object apart, the bonds will pull them back together to their original size. Having talked about contact forces, we'll now look at non-contact forces. How many different non-contact forces can you list? Pause the video now and try and think of as many non-contact forces as you can think of and list them in your books under the title Non-Contact Forces. There are electrostatic forces, for example when you rub a balloon on your hair and then stick it to a wall. There is magnetism and there is gravity. All three do not need to be in contact with the other object in order to exert a force. We're now going to look at how Newton's third law of motion can be applied to high diving. High diving is the act of diving into water from extreme heights. In 2013 at the World Aquatic Championship, a new competition was introduced, a high dive from 27 metres. The highest diving board in the Olympics is 10 metres. From this height, divers take up to 3 seconds, with the diver reaching speeds of 90 km per hour before entering the water. In this diving competition, divers enter the water feet first because of the high risk of head injury. The water stops the divers in less than a second and they rarely go deeper than 4 metres. In your books, I'd like you to name one contact force and one non-contact force acting on the diver as they are falling through the air. Don't forget to pause the video while you answer. Possible answers for the contact force are air resistance or drag, or possibly the push of the air on the diver. You'll also be allowed friction. And non-contact forces, well, obviously gravity, or the force due to gravity, or weight, or gravitational attraction of the earth on the diver. For the contact and non-contact force you named in question 1, identify their equal and opposite forces. Again, don't forget to pause the video while you answer the question. Have words to the effect of the diver pushing on the air and the gravitational attraction of the diver on the Earth. If you'd like to stretch yourself in this topic, pause the video now and have a go at this extension question. If you've attempted the extension questions, pause the video now and use the mark scheme here to mark your work. For our final question for all of you, sailing can be difficult when there's no wind. What would happen if someone placed a fan on a boat and used it to blow air into the sails? Pause the video here to answer the question and feel free to use a diagram if you think it will help with your answer. The wind from the fan would exert a force on the sail to the left, but to move the air, the fan would have to exert a force on the air to the left, which means the air would exert a force on the fan, pushing it to the right. The total force acting on the boat, from both the fan and the sail, would be equal and opposite. So the resultant force would be 0, and the boat still wouldn't go anywhere. Instead of having the fan pointed at a sail, the best option would be to have the fan pointed backwards, pushing the air backwards and the boat forwards. And this is exactly what they do with the airboats on the Florida Keys. Well, that brings us to the end of today's lesson. I hope you found this useful, and thank you very much.